Good morning, good afternoon, scholars. What we're going to do now is we're going to continue from where we left off on Friday. And we started with learning how to graph these pretty crazy rational functions by hand. And so in most classes, we got through the first two and even maybe the third example. But what I want to do is I want to go back and do the third example and then maybe show you a few more. And then I guess we'll conclude this section. And so just a reminder, this coming Wednesday or Thursday, depending on when you have me on our block schedule, is our next assessment. And it's the entire chapter 2. So I strongly suggest that you go through the study guide that I provided for you. The answers are on the website, and also the practice problems. So get nerdy, get cool, and stay in school. Yeah. All right, so here we go. We're going to go ahead and start cracking down this guy. So here's our rational function. And what I want to do first, I'm just going to go ahead and factor the denominator here first, just so that that's already done for us. So I'm just going to rewrite our rational function as x over x minus 2 over x plus 1. Okay, so that's like the same thing as that. So y-intercept, that means f of 0, right? I plug in 0 in for x to determine what the y-intercept is. So if I plug in 0, 0, 0, well, that means I'm going to have 0 over negative 2, which is just 0. So that means that's the coordinate point 0, 0. Okay, so that happens to be our y-intercept. Our x-intercept is when we set the numerator equal to 0, right here. So x equals 0. And that's it. So that's where it's going to cross the x-axis at 0, 0. Very nice. Vertical asymptote means when does the denominator, what x value will make the denominator 0? So if I plug in a 2 right here, won't that make the denominator 0? Right, because it's 0 times that. Or if I plug in negative 1, that will make this whole thing 0. So that means I have 2 vertical asymptotes at 2, and I also have one at negative 1. Okay, so just to review there, the way that you find the vertical asymptotes is really like you set the whole denominator equal to 0 and then you solve for x. So if I set this equal to 0, I would do x minus 2 equals 0. So that means I add 2 to both sides before I get my 2. X plus 1 equals 0, minus 1, and so that's how I got my negative 1 there. Coming along over here, horizontal asymptote. Well, since my n is 1 and my m is 2, if the numerator is smaller than the denominator, then that means you always have a horizontal asymptote at y equals 0. All right, cool. So before we get to the additional points, let's go ahead and plot what we have here. Well, we have a y-intercept and an x-intercept at the same point at 0. All right, so let's go ahead and plot that dude right there. So we'll just go bloop. Okay, so there's that. And then we have an x-inter or a vertical asymptote at x equals 2 and at negative 1. So let's see if I think I could use a little dotted line thing here. Just be kind of cool. So let's go like this. Oh, pretty fancy schmancy. Oh, and also at negative 1. So just like that there. All right, so those are our asymptotes, and we have one more going across this way. I'm going to kind of do it just above it so you can kind of see it there. Awesome. So we have our asymptotes, and what I want to do here is let's just find out what's happening over here. Okay, so this is now when I'm going to start doing my additional points. So I know I can't plug in negative 1 because that's an asymptote, but let's plug in negative 2. What happens if I plug in negative 2? And since you won't have your graphing calculator, you're going to have to, this is when it becomes the most tedious now, because now you're just going to have to plug in these x values. And you could use your factored one or the one that's over here. So if you plug in negative 2, you would get negative a half. So if I go to negative 2, I get negative a half. All right, well, that's not really enough information right there for me. I'm going to plug in negative 2. Oh, I'm sorry, I just did that right now. Let's plug in negative 3, right? 1, 2, 3. So what happens when I plug in negative 3? So if I plug in negative 3, then I'm going to get negative, let's see, that's going to be a negative 0.3. And I'm just doing these real quick on my calculator, but obviously you will need to do all the work right here to find these points right here. So negative 0.3 about like right there. And you can kind of see that these all follow the same kind of pattern. So this guy's going to look something like this then. It's going to get really close, and then it's going to kind of teeter down, and it's going to get really close right there. And that's the way that that part's going to go. Okay, we'll do the middle here in a minute. Let me just go on this side, and let's find out what happens at f of 1, 2, 3. If I plug in 3, then I'm going to get 0.75 or 3/4. Okay, and if I were to plug in 4, let's see what happens when I plug in 4 right here. I would get 0.4. Okay. So let's see, 1, 2, 3. So at the 0.3, and that's going to be 3/4, and then 4, and then even smaller. And so you can kind of see it's going to do the same little thing here. And get really close over here, and right there. All right. Now, obviously, it's not supposed to touch the asymptote right there. Just when you're writing on this little pad here, it's not the easiest thing. But so yeah, so it's going to ride along it just like that there. And you know what? If you've already started and practiced some of these problems from 2.7, you're always going to see this pattern where if you have a graph that looks like this on one side, you'll never have one that's over here. It's always going to be on the opposite side. And so, you know, once you start seeing that pattern, you know what it's going to look like, and you can kind of generate that a little quicker. But what's going on over here, though? This is when it becomes a little tricky. And so we have 1 point at f of 0. And so we said f of 0 was 0. But what's happening maybe at 1? If I plug in f of 1. If you plug in f of 1, that's going to give you negative a half. Right here, and then negative a half. Let me just share with you another cool trick here. When you have these double asymptotes, you're always going to have a really interesting phenomenon, and that is you're always going to have this point of inflection. You know, kind of like that cubic curve, like this kind of thing. All right, so as you can see here, it's going to go down and then keep going over here. So I'm just going to go ahead and just draw that in right now. Something like that. Okay, and that probably wasn't very apparent to you right now. I mean, just by looking at it, like, okay, dude, how do you get that from just those 2 points? That's why you probably may have plugged in maybe a half right here, and maybe plug in like 5 halves, and then maybe plug in like negative a half. And what it's going to do, it's going to give you more points, maybe like right there. It'll give you a point here, and then maybe like you would get a point right there. But once again, it's through the repetition of practicing these, and like you start to see these patterns that, oh, when I have vertical asymptote, it's going to do this little point of inflection, and once I have a point in here, I know it's going to do this thing. So that's why I strongly recommend that you do all the practice problems, because the more practice is going to be a cinch on the exam. And if you don't practice this, you're going to probably spend a lot of time on just one problem, and that's probably going to hurt your grade there, because it's very long, 2-hour exam on Wednesday or Thursday. Okay, if you need to pause the video, you can, or we're actually just gonna, I'll probably stop the video right now, and then I'll do a new video for our next example.